Okay, so it's a pretty good time to get started. So welcome to class, everybody. So just a couple of notes before we get started. There's a number of you that may be on the wait list. Considering that nobody's standing in this room right now, I think probably all of you should be able to get in. Probably there's people who signed up for the class who didn't come to lecture today or might not be able to come to lecture for the first few times. So just wait a little bit, and probably we're going to have some folks drop the class. Now, typically, when people start a class, they'll sort of hand out a syllabus, talk about assignments and grading. And we're going to do that towards the end of lecture today. But instead, I wanted to start with a description of this class overall and what my goals are in terms of the skills that you're going to have when the class is done and how we're going to get there. So the first sort of key question, and this is a question you should probably ask for every class that you're enrolled in, is why does this class exist? What am I supposed to get out of this class from being in here, 3 hours a week for the rest of the semester? So why does this class exist? And the reason it exists is because coding is a key skill. It's an absolutely key skill for multiple reasons. So first, it's a key skill for future employment. So many companies nowadays have coding as a key part of the interview. So for example, if you were to interview at Google, one of the things that they do is they'll talk with you maybe on the phone for an hour while you're opening up like a Google Doc and they're asking you to code like right in front of them, right? So they're watching you code as they're giving you the problem. And Google's not the only company that does this. Many companies do it in various different kinds of styles. But quite often it's a time-limited kind of interview. So they give you a problem and they ask you to create code to solve it right there. And if you don't pass that, you don't get the job, basically. It's an absolutely key skill for future employment. So one is to pass the interview, but other key skills are that once you actually go into a company, nowadays oftentimes coding is just a key part of the infrastructure of that company. So you have to have skills to do things like understand the things that other people have written, right? Because there's going to be hundreds of people that worked at that company before you got there that developed a whole bunch of code that you have to learn how to use because you can't sort of re-implement it on your own from scratch. You're also going to have to add to that infrastructure, right? So after you learn what other people have done, the company might ask you to sort of build some modules or build some things that sort of build on the existing infrastructure and make the company better in some way. And to be able to do all those things, one of the key things that we're going to learn in class is how to learn about available tools, how to exploit the tools that are available to you without somebody actually helping you on a one-on-one basis. So a big part of this course is going to be you learning how to use tools on your own. So that's one reason that coding is a key skill. But another reason, and this is especially important for those of you who are PhD students in the class, is that coding is an absolutely key part of your thesis and your research most of the time. So many of the classes that you've signed up for and are taking are fantastic classes in terms of telling you the theory of how to do things. You may have proved lots of theorems. You may have learned some algorithms in there. But ultimately, when it comes down to publishing a paper or doing your thesis, you're going to have to run some computational experiments. You're going to have to process some data. You're going to have to do some statistics on that data. Whatever it is, coding is an absolutely key part of that. And I can tell you, both myself and essentially every other professor throughout the university is looking for students with this skill to sort of give RAs to and so forth. So it's something that people definitely take into account. So in your thesis and research, you have to do things like invent and implement new and efficient methods, prepare and run computational experiments, prepare custom visualizations. This is a really important one for publishing, right? So all of you are familiar with sort of the things that you can do in Excel by creating a chart. But in this class, we're going to learn to expand your abilities to create custom visualizations tremendously. And I have a few examples of that later in this presentation. And of course, a key part of that is to prepare compelling presentations. And that goes along with preparing visualizations and preparing computational experiments and so forth. So let me give you a little bit of background about myself and also tell you about places in my past experience where these skills have come in useful. So one of the things that I did for a while was I worked for Amazon.com. So Amazon has a product database that's over 1 billion items big. So there's a tremendous amount of computational tools that go in the back to actually make your Amazon shopping experience even feasible, right? So when you go in and you type, like I'm looking for a bike or this kind of bike lock, Amazon has to search through all those billion items to deliver an item that's appropriate for you, or perhaps most appropriate for you. And so one of the things that I worked on at Amazon was automatically understanding what the item is from the item description. So the way that Amazon works is there's many retailers that sell their products on Amazon. It's not just Amazon that's selling products. And a retailer will often enter an item description with a long sentence like this, like double lock, unlock, bicycle, cycle, so forth, BMX. Maybe they'll have even the color in the title, blue. But in the Amazon database, each of these things are a separate field, right? Like, what kind of item is this? Is this bike lock, or is this a bike, right? What color is this? That's a separate field. I don't want that in the title. I want it in the color field so that if people are searching for a blue bike, I can give them only the blue bikes, right? And so there's an automatic process called segmentation that can take that sentence and break it down into its component parts. So it's one of the things that I did at Amazon was taking these long sentences and building a program that automatically segments out the parts so it can be inserted into the database for efficient searching and for filling out missing data in the database. And similar to you in class, at the beginning of my work at Amazon, I literally knew almost nothing about how to do this. So it was all through reading various documents and understanding how to do this over the time that I was at the company. So let me give you another example. So this is a finance example. So on the horizontal axis here we have time, and on the vertical axis we have percentage. So everything's kind of normalized. We don't get the absolute dollar value, but just percentage. And these are various stock tickers. And 3 of these look similar, and 1 does not, right? So just by visual inspection, you can tell that these 3 are somewhat similar, and that one looks a little bit different, right? So this is a really important thing for hedge funds that are choosing what companies they should put billion-dollar portfolios in. Because if they happen to invest in all 3 of these companies at the same time, and those companies are related somehow, and they all take a dive like they did around this time, then the entire hedge fund portfolio is going to take a dive. And the entire point of hedge funds is that they should be hedged against these sort of common moves in the market. So if all the companies go down, they don't want the hedge fund value to go down at the same time. And so there's a process that they go through where they try to identify essentially market segments, or you can think of them as industries. And so if I just remove the blackened area here, we can see that this green stock is Caterpillar, and the other 3 stocks are Amazon, Google, and Yahoo. So the 3 stocks that moved together were all sort of tech companies, right? And Caterpillar is not a tech company. It's more related with the construction area, and so it behaves fundamentally different than the tech companies. And that's something that a hedge fund has to do, has to identify these groups of companies that move together automatically, because they're investing typically in thousands and thousands of companies, maybe in multiple markets. And there's no way that they can individually sort of go through each of the companies and decide, oh, this one behaves like that one, oh, this one behaves like that one. It has to be all kind of an automated process. And of course, regardless of those 2 particular projects, one key thing that happens at essentially every company is that decision makers have too much data available to them, but they need that data to be concentrated into easily understandable bite-sized pieces so they can actually make a decision. And the key part of that is what now often is called business analytics. So business analytics often is just roaming through the company's databases to produce relevant and interesting figures for decision makers that is going to allow them to produce decisions that are going to make the company better. And as a key part of that, the important thing is how to understand or how to be able to construct these kind of meaningful visualizations, right? So Google does a lot of this. So Google Maps is a key kind of thing that you might be interested in, because maybe if you're a company, you might be interested in how your sales are doing in different parts of the geographic region and so forth. There's, of course, pie charts, time series, and so forth. These you're more familiar with from your Excel experience. But creating these custom visualizations is an important aspect of both companies and research work. So let me give you an example from my research work. So one of the things I did as a postdoc was I worked for several years on trying to figure out how to interdict nuclear smugglers. So how to make it harder for a nuclear smuggler to take a nuclear material across a transportation network. So throughout that, the way that we started that project was we created a really simple version of it where we, instead of thinking of a smuggler, we thought of just a mouse moving through a grid, and we're trying to get the mouse to this position here. And the mouse starts at this position here. But this visualization is something that I programmed myself. It's not available in Excel. There's no button that you're going to click on that's going to produce this thing for you. And it communicates key parts of the problem that are there. So for example, this mouse is randomly moving. So these circle sizes are the expected time that the mouse spends in each cell. These bars here represent various controls that you can put on the mouse, like blocking him from moving from one cell to another. So for example, can't move from this cell to that cell. And there's two key squares here, this one and this one. If the mouse ever makes it to this cell, he dies. And if the mouse ever makes it to this cell, the game ends and you get a reward of 1. So all the various controls are built to prevent the mouse from going into this cell and make him go into the top cell as quickly as possible. And to give you another example, so one of the things that also often happens with code is over time you improve things, right? So you start with a particular visualization, your code works for a while, but then you want to make it a little bit better. And so a little bit later, I created the following visualization, again for the mouse and cheese game. So this is a cheese where I want to get the mouse. This is a mouse. And these various arrows represent controls that the mouse has. So now he can choose which direction to go in. The darkness of the arrows represents the expected time that the mouse spends in that particular cell. So he's much more likely to go in this direction than to be in this part of the space. But as the mouse moves, he gets bumped along the way. And so that's why you see sort of dark areas surrounded with these gray areas. But of course, if he gets bumped too much this way, he tries to get back to his plan, which is to move in that direction. So these are just examples of custom visualizations and the kinds of things that you might want to create for your research project. So here's another example of a custom visualization. So this is more of a geographic-based one. So I moved from the mouse to actually using real-world networks. So this is a map of Pakistan and India. And I was running an example where I have a smuggler that starts out in Peshawar. He's trying to get to Karachi. And he's getting bumped along the way. And these are various detectors that we can put along the way. And so the smuggler tries to go around these detectors and get to his destination. But again, something that unless I was able to program, there is absolutely no way I would have produced this visualization. And it goes tremendously far in terms of both getting papers published, getting grants accepted, all kinds of other useful things from your point of view. Also, by the way, incredibly useful for presentations, whether it's an interview presentation in an academic job or a presentation to a customer if you're working at a company or what have you. So here's some other examples. This is one from disease surveillance where I was looking at what areas in Texas should have doctors that report to the state the occurrence of a particular disease. So you can see lots of customization here in terms of arrows, in terms of the order in which these doctors have to be added to the state surveillance system. Other examples, there was a disease simulator in the back here that sort of simulated the way that influenza would spread throughout Texas. There's a tremendous amount of data, so each of these arrows comes from census data that measures the amount of movement from one city in Texas to the other. The thickness of these lines is proportional to the number of travelers between those cities on a daily basis. So as you can see, Austin and San Antonio have much thicker lines than, say, Austin and El Paso, because there's a lot more daily travelers between those cities. Again, both the data processing and the visualization and the simulation as key things that would not be possible without the coding skills that hopefully you're going to gain in this class. So this is some simulation optimization results. So both in research and in companies, like problems have several aspects to them. So one is processing a bunch of data. The other is maybe doing some simulation or some statistics. But there's also an optimization problem, some decision that has to be made. And so this was a decision on how many antivirals to release in the state of Texas to try to stop the spread of the epidemic. And in the background, it has that simulator, which I showed you in the previous slide. So there's tons and tons of simulations that ran to do this. And in fact, to run this, we probably used about 3 years worth of computing time. So think of like your desktop or whatever working for 3 years on your desk. Like that's never going to happen if you actually used your desktop. So one of the key things that we're going to learn in class is how to do parallel computing. Because a lot of these large data, large computation tasks, you can do in parallel, and it'll significantly speed up your research progress and your ability to do analysis. So what are ultimately the goals for this class? So my goals for you are to become comfortable designing computationally efficient programs for optimization. So there's many different ways to write a program. And some ways of writing the program means that it'll never complete, and other ways means that it'll complete really quickly. And we're going to see various examples of this throughout class. My second goal for you is to practice implementing advanced optimization algorithms. So we're going to ramp up in class. At the beginning, it's going to be relatively simple things, some matrix operations, some plotting. And by the end, one of your final assignments is literally going to be, here's a research paper, implement the algorithm that's in it. Because that's the skill that you should have, especially if you're a PhD student. The third one is to learn some tools to help you achieve your employment and research objectives. Okay, so now that you know what the goals for the class are, the key question is, how are we going to get there? So the plan is that the entire course is going to be based around programming projects. So expect one of these about every 1 to 2 weeks. And the reason for this is that ultimately there's absolutely nothing that I can say in lecture to have you learn this material. Like the only thing that's going to help you learn how to do this is for you to actually do it. For you to actually spend the time to create these programs. And so the course is organized around that. The projects are going to ramp up in complexity, like I said. We're going to start with things that are relatively simple and increase the complexity as we go along. In terms of lecture, we're going to have a very different kind of lecture. It's going to be very few slides, so nothing like what we're doing today. Most of the time, it's going to be demos. So it's going to be me programming together with you. I'm going to have a programming interface open. We're going to have discussions. I'm going to be telling you about various tools and showing you examples of how to do that in class. That said, there is no way that what we talk about in lecture, like absolutely no way that what we talk about in lecture is going to be sufficient for you to do the projects. And so a key skill that you're going to learn as you do the projects is how to read documentation. So a lot of times it's going to be a pointer. Here's a website that tells you about this tool, and you have to learn how to use it. And what I can tell you ahead of time is that this gets easier and easier with time. The first time that you start doing this, you might spend a bunch of time reading the website until you find the piece that's actually important for your program. But as we keep doing this throughout class, and as you continue even after the course, you're going to get very efficient at that. So nowadays, even though there might be an entire website of documentation for something, I just go and find exactly the snippet that I need when I need it. And also in general, there's no way to do programming without having access to the internet like this nowadays. Just because the tools are way too complex for you to actually keep all the information in your head. So as I'm developing a program, I often constantly have to look up things online. How exactly do you do this? How exactly do you do that? Maybe even try out a few things. So that said, you should expect to spend some time on actually doing the projects. So that time is going to be spent doing things like learning by searching online, trying things out yourself. So oftentimes when you try to program something, the first time you program it, it's not going to come out right. So you're going to have to do a bunch of debugging. And we're going to learn debugging tools throughout the course as well. But also a key part, which is going to help you tremendously, and it's something I just want to encourage from the beginning, and it's going to be encouraged throughout the class, is I really encourage you to talk with and help your classmates. So it's very well documented that group learning is actually much more effective than individual learning. So what I mean by that is discussing with 2 or 3 of your classmates, oh, how do you do this part of the project? How did you do that? How did you do that? I don't consider that cheating at all. Instead, what's actually happening is both of you are learning. Both the person asking the question and the person answering the question is actually gaining something. The person asking the question maybe is getting a deeper understanding of the topic, understands how to do things in a slightly different way than they were thinking. And the person who's answering the question has to formulate whatever they did into an explanation. And that process of formulating an explanation usually really crystallizes things in your own head. And so basically everybody wins from working on these things together. So you should think about this class very much as kind of a group experience, right? And I mean that for everybody. So we're going to start with, and I'm going to talk a little bit more about it later today, installing the tools on your computers. I'm not going to individually help you install the tools, but I guarantee you there's going to be 3 or 4 of you who are going to figure out how to do it just fine. And it's your job to sort of help everybody else install things correctly on their computers. So what about the exams? We're going to have a totally different kind of exam. So typically you're used to sort of a piece of paper sitting there for an hour and a half, answering some true-false questions and so forth, maybe writing a short essay. These exams are going to be like coding-style interviews. So what I mean by that is we're going to have an in-class, time-limited programming assignment. You're going to walk in, there's going to be a problem that's going to be posted, and by the end of the time period, you have to turn in working code. And there's a very good reason for that, because having that skill is going to help you get jobs, right? And so I want to help you practice to get there. And so we can even do some practice exams before our first exam so that you can get comfortable doing this. But it's absolutely an important thing to be able to do because there's a huge difference from a company hiring a programmer that can do something in an hour versus the programmer that can do the same thing in a week, right? They want you to be efficient in your construction and your thinking of code, and we're going to practice that in the exams. So you're going to have to complete this set of tasks. Some are going to be based on the tools we learn, but on the exams I might put something that we haven't talked about. Okay, like maybe some part of a tool that we didn't discuss in class. But what's going to help you is that the exams are open internet. So you can use literally anything to help you complete that problem, except talk to somebody. Like that's the only thing that you can't do. So you can't text message your friend who's over next to you or something like that. But you can look up all the documentation you want. You can use whatever code snippets you find online, exactly like you would if you were programming that at a company, right? Like what's detrimental to the company is going over to the person in the next cube and having them program it for you, because they might as well not have hired you then, right? But if you can figure it out on your own, fantastic. And so a final thing that we're going to do is we're going to do a final small group project that's going to be a big part of your grade. So we're going to talk a little bit more about this shortly, but for this small group project, what I want you to do is pick something that matters to you. So you're going to be spending a lot of time on this, especially towards the end of class, a lot of time programming and thinking about this carefully. So pick a topic, I suggest, that double counts in some way. So pick something that works for your thesis, or pick something for a company that you want to start or are thinking about starting. So like as an exploratory thing, like is it worth it for me to do that? Maybe for a paper that you're doing, maybe you can take that coding assignment for your paper and turn it into the class project. And the choice here is important because I want you to spend time on it, not because it's a class project, but because you actually care about that particular topic. And that's going to make for a much more useful project for you and a much better result for the class overall. And at the end of class, we're going to have presentations and various write-ups for these projects that are going to help everybody else learn about what you learned throughout the course of developing your particular project. Okay, so in terms of the tools that we're going to use, some of you may have looked on the course website already. We're primarily going to use Python for all of our programming. So there's a reason, there are several reasons for this. So first is that Python has an incredibly rich set of packages. So what I mean by that is that most of the tasks that you think about doing, somebody's already written some code for that. So that can help you tremendously in terms of getting to the place where you want to be quickly, because you don't have to re-implement many things. In addition to having these packages, it has a very active community. So there's all kinds of message boards online that you can post questions on that people will answer, and a rich set of documented questions, right? So oftentimes you can just search for your question and somebody's already asked it and answered it on some website. It's heavily used in companies like Google, Yahoo, and so forth. It's heavily used in universities. So for example, Carnegie Mellon and MIT, all of their introductory computer programming courses are in Python. So it's not like we're doing something that's out of step with what the rest of the world is doing. There's other nice things about the language itself, that it has a nice legible syntax that allows you to focus on what you're doing instead of how to do it. So there's a difference here. And just to give you an example, how many of you have programmed with Java before? So for those of you that have done a little bit of Java, printing hello world in Java takes something on the order of like 20 lines, right? Printing hello world in Python takes 1 line. And that is it's gonna become obvious to you like over and over again as we learn these Python tools, that there's a bunch of tools that reduce the amount of code that you have to write. Oftentimes it's just 1 line, but the question is figuring out what that 1 line is, as opposed to sort of programming for loop after while loop and so forth. There's lots of tools that exist for the things we do, especially for scientific computing. There's lots of really nice Python tools. And of course, it's free and open source, and you can use it after UT wherever you happen to go. So what are the expected learning outcomes? So these are the things that I hope that you gain from the class. To become comfortable designing programs. And what that means is that I want you to be able to organize your code so that you can go back to it after a month, after you've completely forgotten what you wrote, and be able to edit it. So I don't know how much programming background all of you have, and I'm going to ask you over the next homework assignment to tell me a little bit about that. But oftentimes what happens is we'll start with a small program, and we'll add a little bit, and we'll add a little bit, and we'll add a little bit, until it gets super long, and then it's incredibly difficult to actually figure out what you did where or change that program. And that's what hopefully throughout class we're going to learn to avoid by organizing code in a nice way, by learning how to debug things. So when there's a bug, how do you actually find out where in the code it is so that you can fix it? There's really nice tools for that. And how to build complexity on top of past things that you've created. So we're going to start small and build more and more complex programs from those small building blocks. The second thing I'd like you to do is become familiar with the tools to get the job done. So there's tools for data processing, visualization, and optimization. And we're going to hit like a huge variety of those throughout the class. And then these are in smaller font because they're smaller goals, actually. Okay. And I'd like to point out that typically this is reversed in most classes. So the smaller goals for me are to implement and understand some advanced optimization algorithms. So we're definitely going to do this, but that's not the point of the course. Like some of those things may or may not be useful to you. It might be useful for a future project you do, but I know this is going to be useful. Okay. And then the second sort of small goal is to improve your writing and presentation skills. And you might think that, well, we talked about visualization, and certainly that's a big part of presentation skills. But writing and presentation skills are also an absolutely key thing that companies look for, and academia and research papers and so forth look for, right? So I think that working a little bit on this can help you tremendously in the future as well. Okay, so let's get started. So to do that, I'm going to pass out the syllabus, and we're going to go through a little bit of the more boring style class stuff. So I have a copy of it up here on the screen, so while it's getting passed around, you can just look up here. So there's going to be a couple of websites for the course. So first is the course website that's just on my personal website, and I can show it to you just now. So if you go to that website, it looks like this. So if you click on courses, you'll see various courses listed here, and that's our current course, the Computational Optimization course. If you click on that, here you'll find a website with various useful things. So first on the right-hand side is a class calendar that has various things like different homework assignments, the date of our exams. Those might get moved as we continue through the semester, but that's the planned dates. Here you'll find various links like the syllabus, the class flyer, some lecture contents, like today we're going to just talk about class goals and introduction. This is also where we're going to post the videos from the class lectures if those work out to plan. And of course I'm going to post various homework assignments here, so I'm going to hand out this project one a little bit later. And at the bottom, you're going to see a link for course resources. And this is just some links to various websites online that might help you a little bit with getting the programming assignments done. So these might be useful to you towards the beginning of the course, and later in the course you're going to become so familiar with these things that you're probably never going to look at this part of the web page. But just in there, some things are some Unix introduction links. So all of you should have gotten an email from me that gave you a login to a research computer. So the only reason that I do that is should you choose to not install the various Python tools that we talk about in class, you can log into that research computer and all the tools are installed there. So there's always a way for you to actually get the work done. Even if you, for whatever reason, you don't want to install it on your laptop, it doesn't work, you can use that remote computer to actually get your work done. Then some links to Python tutorials and some other links to key Python modules. Okay, so in terms of office hours, so you all know when the lectures are. In terms of office hours, they're Wednesday 12:30 to 1:30 and Thursday 2:30 to 3:30. In terms of email, so one of the things that happens especially in programming courses is I get lots of people emailing me things like, oh, here's my code snippet. It doesn't work. Can you help me figure out where the bug is? So no, like I will not respond to any sort of technical emails. So in terms of emails, feel free to send me administrative concerns or questions. Things like, oh, I need to miss this exam. Can we reschedule? Like, you know, I missed this homework assignment, something like that. But if you have questions on class material, you can ask them using Canvas during office hours in class, or email me to schedule an appointment. Okay? So what do I mean by asking these questions using Canvas? So remember that I said this is kind of a group learning environment. So if you click here on the Canvas website off of our class website, it'll take you to Canvas, and there's a discussion link. Okay? So this discussion link is available to all of you. And what you can do is you can post questions about assignments there, and other students from the class can answer you. And so that's a really nice way of getting questions answered quickly without waiting for email or scheduling an appointment from me, or maybe even without waiting to actually meet with somebody from the class. Because anybody from class who actually understands that particular topic can post an answer to help answer your question. So I strongly encourage you to use these discussion forums. It's worked out really well in the past whenever we've had a group of students that are active to both post questions and answers there. So the course objectives we've gone through. In terms of prerequisites, in general, there's two things that are important. Some basic understanding of programming. So all of you should know about if statements, while loops, for loops, and so forth. If you don't, you're missing a key background for the class, and it might be difficult for you to actually complete the homework assignment. I'm not saying it's impossible, but it would probably be difficult. So having some introduction to programming is useful. And second, having some introduction to optimization or algorithms. Because we're going to have to combine these for loops and while loops to do complex things, and that's ultimately an algorithms kind of so kinds of classes that are useful here are linear programming, algorithms, networks, so forth, and maybe more advanced ones like convex, dynamic, linear programming, and so forth. So we talked a little bit about the course content in terms of the lectures. There's going to be a lot of reading on websites. So let's talk about assignments and evaluation. So the homework assignments are going to be about 40% of your grade total. So those are the various projects that we do throughout the course. So I encourage you to discuss these assignments with your classmates. So by the time that it comes to turn in that assignment, I expect essentially all of you to have working programs. Because if you don't have a working program, it probably means you didn't talk to enough people. Okay? So, but at the same time as you're talking with people, be sure to make it a learning experience, right? So imagine that it's getting close to assignment due time. Like, I don't want you guys to just give your code to like your friend or something like that. Instead, help them understand how to code it, because otherwise it's kind of not doing anybody a favor, if you understand. So help them understand the key parts of the assignment. So never copy someone's code or give your code to somebody. Instead, discuss how to code and debug with them, and only after you've expended a good amount of effort yourself. So, yeah. So in terms of late penalty, I know all of you have complex life schedules outside of class, and because of that, you can turn in one assignment up to 2 weeks late without a penalty. So I'm not going to ask any questions. You don't have to give any explanation. One assignment you can do late for up to 2 weeks. But other than that, turn them in on time. There's going to be 2 exams, 15% each. So these are going to be the in-class programming assignments that I talked about. And the only rule there is that you have to complete it entirely on your own. You can't talk to anybody, but it's open internet. And then there's going to be the final project that's going to be 30% of your grade. This is the rough class schedule. So a couple of exams, and then the last few weeks of class, maybe 2 to 2.5 weeks, are going to be project presentations where we get to learn about all the cool things that you've done using the tools that we learned about in class. So just some things that I think are useful for you to keep in mind to make this a successful learning experience for everybody is communicate with me when you're lost or don't understand or think we should spend more class time on a difficult subject. So it's much more important for me that you guys have a good learning experience than it is for me to actually cover the topics that I have here, right? So that means ask questions, talk to your classmates. If you think that we should recover something or do something again to help you the class actually understand everything, let me know, and we can adjust class as we go along. So help and seek help from your classmates, create a group learning environment. We're all in this together, and we have the same goal, which is to actually gain these skills by the end of the semester. And number 3, which is expect to do the majority of your learning outside of class time. So it involves a lot of coding because that's the only way that you're going to gain the ability to do that. And then the syllabus just ends with some lists of concepts that we're going to learn. So these are just key Python tools that are going to help you do things. So just to highlight a few, SciPy is the scientific computing environment. Pandas is the main data manipulation environment. Matplotlib is the main module that you're going to use for creating custom visualizations. And we're going to learn various details about these tools throughout the course. Okay, so I'm going to hand out your first assignment, which is to spend some time thinking about that project. So in particular, this is the piece of paper that's coming around. So at a basic level, the class project consists of selecting a programming or optimization topic of your choice, and then you're going to design and implement a complex piece of software to work with data on that particular topic. And then finally, you're going to present your work in class in a presentation at an executive level rather. So this is pretty much the project description. I mean, the project is incredibly open-ended. You can pick essentially any topic that you want that you think is going to be motivating to you and you want to spend a large amount of time on. But here are some sort of guidance for completing this assignment. So select a team of 2 to 3 students. I think the optimal team size is 2 because it gives you somebody to discuss things with so that you're not alone. But also with a team size of 2, everybody's going to get the optimal learning experience out of the actual project. if you go to a team of 3, what I find is typically there's one person out of those 3 that tends to do less than the other 2. And so I strongly encourage teams of 2. Also, you are completely allowed to have a team by yourself. So you can have a team of 1, but I strongly discourage you from doing that for several reasons. 1, I think it's a worse learning experience because you're not going to discuss with anyone throughout it. And 2, it's the exact same requirements, whether you're a team of 2 or whether you're a team of 1. So essentially, you have to do twice the work if you're a team of 1. The only benefit and the only reason that I allow a team of 1 is because I know some people just have very complex schedules and it's difficult for them to meet with others. And so if you happen to be one of those people, yes, you can work by yourself. So it's also beneficial that all the team members have the same applications of interest because you're going to work on the same problem together, right? So it's not like 2 problems you're going to pick, it's going to be 1 problem. And so pick people that have similar interests with you. So select the problem that you're going to be working on. So the best way to define the problem is by the outputs you want. So think about what kind of output do you want your program to produce that doesn't exist right now. And that's going to be sort of the definition of your problem. For example, I want to produce uniformly random points in an arbitrary convex set. So that's a very complicated mathematical thing, but you might have sort of more English language plain ones that are going to be defining your problem. Or I want to be able to route multiple trucks to delivery locations around Austin. So if possible, and I strongly suggest this, pick a problem that's meaningful in real life. And the reason is it's going to really help you in both finding data for it and figuring out if your solution is right. If you pick something very abstract, it's very, very difficult to actually say whether your program is running correctly or not. But with meaningful real life kinds of solutions, you can just look at it and say, hey, does this output make sense? And also pick a problem where there's a lot of data available to help you get your work done. So we're going to be doing a lot of data processing, so try to think of problems where there is actually data on the things that you want to analyze. Also try to pick a problem that's unique to your team, and steer away from problems selected by other teams. So this is to make sure that every team has a unique experience, and also to make sure that the presentations at the end give us a wide variety of interesting topics that we can all learn from. So in terms of the deliverables for this assignment, you're going to submit the following on Canvas. So 1, the names of your team members. 2, the problem you selected, including the goal description sentences. Of course, it's right at the beginning of the semester. I don't expect this to be final. I just expect this to be a sketch of the problem that you want to work on. So you're definitely welcome to edit this and refine this as you go on throughout the course. And 3, description of the kind of data that you're going to use, and maybe some example problems or example links to where you're going to get that data. So I have to approve your problem selection. And for a few of you, and typically it's about 10% of the class, I might bounce your problem selection. I might say, hey, too many people in class selected this problem, or I don't think this is going to be a particularly good problem. And so we might have to do a few iterations until you find a problem that actually works well. So data sources might be sufficient, or your selection might be similar to other teams. And one thing I want to highlight is at the end of the class, I'm going to post all your projects and write-ups and presentations online. So try to pick things that you don't mind getting posted online, right? So in particular, like if your parents own a company and it's sort of sensitive company data that you don't want to post online, it's probably a bad thing to pick as your project. But you could pick maybe something related to that where the data is freely available and just post it online. So some things to consider as you're talking with your teammates. Okay, so yes.
So these are guidelines for the first assignment
That's
or
right.
the final project?
No, these are the first assignment, and but the first assignment has to do with the final project. Okay, so in the first assignment, you're going to pick your topic that you're going to have for your final project. Does that make sense? And we might have several assignments that have to do with the final project throughout the course.
Okay.
Right, so I might ask you to sort of turn in a half-working version midway through the semester to make sure that people don't leave work all the way to the end.
Yeah.
So So for subsequent assignments which are not related to the project itself, do we have to stick to the team member or?
Oh, no. So this team member is only for the project. Assignments, each of you are gonna turn in your own code. So I don't want to see duplicate codes from anybody, if that makes sense. But you're allowed to talk to anybody, right? Not just that one person that's your project team member. Like you could talk to literally every person in class to actually get their own person. Okay, so then I'd like to just continue by sort of jumping into the class material a little bit. By introducing you to some of the basic tools that we're going to learn basically through their documentation websites. So there's several different versions of Python, and the one that we're going to use in class is Python 2.7. So some of you that are familiar with Python might know that there's sort of a 3-point-something version and a 2.7 version. The reason that we're going to use 2.7 is because it's static. It is never going to change, okay? And so that means that in 3 months when a new version of Python 3 comes out, we're not going to have to change our code very much. Now, there's also not very much difference from 2.7 and 3-point-something. So if you learn 2.7, but you go to a company that uses 3-point-something, you'll be able to pick it up like that because there's literally like 2 or 3 key differences between the versions, okay? So we're going to use Python 2.7. And this is the main Python 2.7 documentation. And one of the things that I encourage you to do, or the 2 things that I find most useful in this documentation, is the tutorial. So one thing that all of you can do after class, if you have some extra time this weekend, before our next lecture, whenever you like, is just read through some pieces of this tutorial. Especially if you've had programming assignments in the past, or programming classes in the past, this is going to be incredibly useful because it's going to take you through the various different types of data that are in Python, how to structure loops in Python. That's going to allow you to conceptually map the programming that you knew in the past to how to do it in Python. And we're going to do that in class, but very, very quickly, and so this tutorial might be useful. The second useful piece of information here is the library reference. So the Python comes with an enormous set of built-in modules, which are basically tools to do various specific tasks in it. Now, when I worked at Amazon, I literally, like on my coffee breaks or my lunch breaks, I would spend a bunch of time just kind of browsing through this library reference, learning about various tools, and oh, here's a cool one, here's a cool one. And even though they're not useful at the time that I learned about them, I oftentimes later came up to a particular programming problem where I remembered, hey, I know this tool exists, I should probably just go and use it. And so just kind of browsing through there is something that you might find useful, and I certainly did when I was there. So the 3 key modules that we're going to practice in class and we're going to learn a lot more about is SciPy and NumPy. So how many of you done MATLAB programming in the past? Okay, so over 50%, I'd say. So Python essentially stole all of MATLAB's programming capabilities. And what I mean by that is they literally use the same library in the background. So if you compute eigenvalues with MATLAB and you compute eigenvalues with Python, they're using the exact same C code to do that, okay? And Python has a better interface and better programming language. And so I encourage those of you who are really sort of MATLAB enthusiasts to spend some time reading this NumPy and SciPy documentation. And there's a link on the course website also that provides just one-to-one matchups between MATLAB code and the equivalent Python code. And so if you're really familiar with MATLAB, it should be very easy for you to get used to some of the more complicated scientific computing based things that we're going to learn in Python. The second key package that we're going to learn is pandas. So pandas is essentially a really lightweight database package. So what I mean by lightweight is that it doesn't require a tremendous amount of installation of things on your computer. So just kind of as an arbitrary question, what's a common data format? So if you're interacting with a company and you want them to send some data to you, how would you ask them to send it? CSV, right? So you might say Excel, and lots of people say Excel, and the reason that they say Excel is because that's the tool that most people use for data analysis, right? But CSV in some ways is nicer because it's completely independent of the particular piece of software that you're using to actually analyze the data. So Pandas has built-in tools to both read Excel files and CSV files. It reads them as a table. You can write queries that finds only the rows of that table that are important to you. You can write various code to add columns to the table, remove columns to the table, do computations with them, and so forth. And we're going to learn about that. And so this is incredibly useful for sort of up to medium-sized data sets. So what I mean by medium size is maybe about like 500 megs. Like, you can still do things when you get to about a gigabyte, but when you get to sort of 3, 4, 5 gigs of data, it's useful to go to an actual database, right? So there you might use SQLite or Oracle or Postgres or something like that. The next tool that we're going to use of the sort of 3 key tools is matplotlib. So this is Python's library for computing custom or creating custom visualizations. And an interesting thing here is if you just click on gallery, it has just hundreds and hundreds of pictures of various plots that you might want to create, right? So let's say that you're doing something that has to do with vector flows. And so vector flows you might want to present using sort of a line and arrow plot that looks something like this. So with the matplotlib gallery, you pull up those example pictures. You click on one of those pictures. So I clicked on that picture, and underneath it is a whole bunch of code to actually produce that picture. So what that means is now you can just rip off this code into your program and then edit it to actually create the picture that you want, as opposed to the one that's there. So it's incredibly useful, this matplotlib gallery, and I use it all the time for my various research projects. Okay, so I want to say a couple of words now about installing these tools. So SciPy, Pandas, and matplotlib, and all the various other Python packages that we're going to use throughout class on your personal laptops. Because you might find that useful. You know, it's always nice to program on your laptop. So some of you are going to have Windows machines, some of you are going to have Mac machines, and maybe some of you are Linux users. And depending on your operating system, there's different ways to actually get Python and its tools to run on your computer. So two of the best ways of doing that is what's called a Python distribution. So a Python distribution is just a grouping of all of the packages in Python that's put together by some organization or company. And they allow you to just download all of that stuff together. So as opposed to installing each package in a piecemeal kind of fashion, you install the whole sort of set of packages along with Python on your machine. So two nice, particularly nice versions are, one is called Anaconda, and here you can see that you can download it for Windows, Mac, or Linux. And another nice Python distribution is called Canopy, that's produced by Unthought. So both Unthought and the people who create Anaconda are key developers of the SciPy package. So that's partly what I mean by Python has a very active community, right? So the same people that create these packages create these nice set of Python distributions that are going to let you use it on your computer. So I'm going to let you guys sort of figure out how to get these things running on your machine. There's various other nice ways of installing Python on your computer. So if you have a Linux distribution, there's all kinds of RPMs, or you can do pip installs and so forth. And just one more note, for the Unthought distribution, if you want to install that on your computer, you might have to sign up for an academic account, which you can just do for free off of their website. Okay, so any questions about that? Okay, so then so just to kind of show you how I installed Python on this Windows computer is actually I'm running it on a Linux virtual machine because I happen to like the way that Linux installs Python and works with these various tools. So I'd like to just begin by giving you some of the basic data types that are in Python. And this is one of the first things that you'll learn about if you read through the Python tutorial that's on the Python documentation website. So here are some of the basic built-in data types in Python. So there are strings, and strings are denoted by quotations. And in Python, you can use either single quotations or double quotations. So I've created here a variable called a string, and I've assigned it the value hello. Okay. There's integers. I've created here a variable called a integer, and I've assigned it the value 4. So for those of you that are familiar with things like Java or C++, a key difference between Python and those languages is that you don't have to declare the variable first, right? You can just sort of create it with an equation sign, with an equal sign, as opposed to first declaring it and then giving it a value. So this is a float. This is a list. So a list is a sequence of things. And unlike in C++ or Java, that sequence of things doesn't all have to have the same data type. So if you're familiar with C, if you have an array, it all has to be floats or it all has to be integers or something like that. But here, in this list, I have 1 and 2 as the first 2 elements and hello as the third element. And then there's tuples, and tuples also can have different data types in them. So the first is a string A, an integer 5, and a float 6.0. So in this course, I'm going to try something new. So typically, the way that I teach this class is by using the Python interpreter. So this is the Python interpreter. I just started it by typing in IPython. And here I can execute codes like, for example, saying a string equals hello. So when I did that, it created the variable a string, and now I can do things like print a string. And it actually prints the value of that variable, right? And so I would type here on this interactive interpreter, but one of the new things that's been happening in the Python community is the introduction of what people call IPython notebooks. So what I've pulled up here is an IPython notebook. And the nice thing about IPython notebooks is they provide a record of all the code that we type and its execution results. So that way you can go home and you will remember all the things that I typed into the interpreter, as opposed to having it just scroll through the screen and maybe trying to write down on your notebook what it is that I wrote. So just to give you an equivalent example here. So I've executed this cell. And here now I can type print a string. And it prints the string hello. So it's, again, just an interface to the Python interpreter, but one that at the end of class I can save, and I can post this online, and you're going to have this sequence of things that I wrote and executed for reference if you need them later. OK, so let's talk about some basic operations on these data types. So of course, you can do things like add, divide, subtract integers and floats. So those things you're familiar with. But lists and tuples are slightly more complicated data types. In particular, you need to do things like index lists to get at particular values that are in that sequence. So let's take a look at these two examples here. So remember when I said that Python has a nice, easy-to-read syntax? So without me even explaining this, you could probably guess what this does. So could somebody sort of suggest what this line might do? OK, where would it add it? Yeah, it's going to add the 3 right there. And what would this line do? Say again? Oh, so, you know, that's a good guess. Does somebody else have a different guess?
What did he say?
He said that this will create a list inside the first list.
I think it was just
That's right. It's going to add these 3 elements. But I'm going to show you how to add a list inside a list. In fact, can you tell me how to add a list inside the list?
Use a pen.
That's right. Use a pen. So append and extend are different, right? Extend takes a list of things and adds all those things at the end of the list, while append sticks in one element, right? So if I put this inside of append, it's going to say, take this object, that's a list, and stick it inside of the list. Right? And let's just execute those lines to see what happens. So so let me execute this. And then here I'm going to print a list. And it did exactly what you guys told me it would do. So this is the original one, 1, 2, hello. Then we appended a 3, and then we extended it with Ned 6, 7, right? But then we might want to do a list dot. Okay, so let me tell you about something useful here, which is that unlike MATLAB, but like C++ and Java, Python is object-oriented. So that means that each little piece of data is both data and associated operations with that data. So to give you an example of that, a list has data in it. So it has this data, 2, 1, 2, hello, so forth. This is the data. But it has associated operations, like append and extend, right? And this dot basically says, do this operation on this data, okay? So one of the key things that you might want to ask is, I have an object, what are the operations that are associated with it, right? Like, what can I write after the dot? And so if you're using an IPython notebook, the way that you can figure that out is to write the name of the object. So here it's a list, and then press tab. So if I press tab, it gives me a list of all of the actions that are associated with that object, all of the things that I can do with that object. So I can append to it, I can count, I can extend, index, insert, pop, remove, reverse, sort, so forth, right? So in this particular case, I want to append. And I'm going to show you in just a moment how to figure out what each of those operations do. So I'm going to append to it, and here I'm going to append the list Ned 6, 7. Right. So that was the alternate operation that we talked about. And then here, let me print a list. Okay, and you can see that this looks significantly different, right? So this is what you said, actually sticking that list within the other list, okay?
Are those indexed just following the previous list?
Fantastic question, fantastic question. So that was going to be my question to you. So my question is, how do I get at that 6?
Is there a pair of indices now?
There is a pair of indices, that's right. So can somebody help me get to that second 6 that's on that list?
I reckon -1, corrected 1.
Okay, so a list. So certainly I have to index in there. So somebody said -1. So they said -1 because they're sort of a more advanced Python user. So one of the things that Python allows you to do is typically you index things this way, right? And unlike MATLAB, Python indexes starting from 0, okay? So this is the element at 0, the element at 1, 2, 3, 4, 5, 6, 7, right? But Python also allows you to use negative numbers as indices, which let you get at the back of the list. So if I index with a -1, it just says, give me whatever's at the end. I don't care how long this list is, give me the thing that's at the end of it, right? So a list -1 is going to give me access to this list, right? But I want to get at the 6 within that list. So what do I do? 1. Or I could also do -2.
Well, wouldn't 1 work in this case too, if the first list is 0?
So say again?
So I understand why -1 would work, but wouldn't a 1 also work if the first list is 0?
You want me to replace this with a 1?
Yes.
Okay, so let's think through that.
Just for example.
Yeah, let's think through this. Well, let me first execute the previous one just to show you that it works. So that prints the 6. And now what happens if I change this to a 1? So it says, go to A list and look at the first element. So what's the first element of A list? 2. And then it's going to say index, look at the first element of 2, which is going to give me an error, right? So let's just double check that that's what actually happens. And so these are the kinds of errors that Python returns. So it's a type error, and it says that int object has no attribute get item. So by the way, those of you that have been programming in Java or C++ or something, right now you should be extraordinarily happy. And the reason is that if you program in C or C++ and you have a bug like this, the result that you're going to get out is segfault, or some kind of really obscure compilation error. Python has extraordinarily nice looking error messages that tell you exactly where the error is, and oftentimes tell you what the error is, right? So if we read this, it says int object has no attribute get item. So int object, because it's referring to the 2, and get item, it's referring to sort of a hidden operation you can do on lists, right? So when we do that bracket -1, what we're actually doing is dot get item, kind of the same way that we did dot append or dot extend, but it's just a much nicer syntax to do this than to write dot get item. And so just saying, like, I can't get an item from an int. You're trying to index an integer. Okay, so one key advantage of Python to many, many older programming languages is the inclusion of the following basic data type. It's called a dictionary. So you can think of a dictionary as a mapping, kind of the same way that a list is. So a list maps positions to particular elements, right? So this is the third element in this list. But oftentimes I want to map other things to pieces of data. So in this dictionary, I'm mapping the string Ned to the number 2 and the string Fred to the number 4. Okay. So let me execute that, and then we can look at the results. And I'm going to print this dictionary afterwards. Okay, so the output is that Ned got associated with 2 and Fred got associated with 4. But dictionaries are really nice because you can associate pretty much anything with anything else. So here I've associated Ned with 2 and Fred with 4, but you'll notice that this is a string and this is a float, right? But I could, for example, associate, let me add some other associations here. So I could, for example, associate the number 3 with the float 7.8, right? So now the same way that Ned was associated with 2 and Fred was associated with 4, 3 gets associated with 7.8. So in this particular way of creating a dictionary, the way that this works is just list the thing that you want to associate and the data that you want to associate it with, right? And you just give me a bunch of these pairs, and I'm going to create the dictionary out of these pairs. But there's many other ways to create dictionaries. And one way to do that, or one way to in general get information about things in Python is with what's called the help function. So I find this really useful sometimes. So let's just do help a list dot append. Okay. So you can pass in essentially anything to help. You can pass in an object, you can pass in a method on that object, and it'll give you some built-in information about that particular object or that particular method. So if we couldn't, just from the name append, figure out what it does, we could call help on append, and it says, append an object to the end, right? Kind of the same way that you guys figured it out. But another thing that we could do is, in addition to help, is dir. And what dir does is it lists all the associated actions along with that object. So a dictionary is an object, and it has many associated actions with it. Many of those actions are kind of hidden actions, the same way that putting those brackets around the one called get item on the list. There's various other sort of hidden actions like delete attribute, del item, dot, EQ, and so forth. So these are not the important ones. The ones with the underscore aren't the important ones. The ones without the underscores are the ones that you're going to typically call. So on a dictionary, those are things like clear, copy, from keys, get, passkey, items, iter keys, and so forth. So let's maybe try a couple of these on a dictionary to see what it does. So let's see what a dictionary.keys does. So I'm going to leave this here and then start a new cell. So let's see. Okay, so a dictionary.keys, when I called that, it created the following list: Ned, 3, Fred. So what are these things? Keys. So dictionary has two things: keys and values, right? The keys are the things that we associated. The keys are the indices to the data, basically, right? So there are 3 indices here: Ned, Fred, and 3, right? And there's 3 pieces of data, which are those floating point values. So that's a dictionary.keys. .values is going to print the values. And what do you think that is going to happen if I do items? Yeah, so those are the key value pairs, all the associations that are in the dictionary. What about if I do, what if I do a dictionary Ned? What's that going to print?
The value.
Yeah, so that's exactly like the indexing operation that we had on a list. The same way that we indexed with a 1 or a -1. So this is indexing that dictionary, and it's going to return the piece of data that's associated with Ned. That's the 2. So dictionaries are incredibly, incredibly useful. By the way, I've done many interviews with companies like that Google programming interview. I'd say in about 95% of them, there's at least one question that the way that you answer that question is by using a dictionary. Right? Because the only way to actually get an efficient solution to the answer is by doing these kinds of associations between things, as opposed to using an array or something like that. So understanding how dictionaries work is a key part of computer programming in general, and it shows up on interviews very often. So I think this is probably a reasonable place to end class for today.